procedure. These are the steps of design procedure. As you can see, the first step is going to be the definition of problem, followed by synthesis. The third step is going to be the analysis of forces. Once the analysis is done, the next step is going to be the selection of material, followed by the very crucial determination of mode of failure. Let's proceed with the sixth step. The sixth step is going to be selection of factor of safety. Once the factor of safety is selected, the next thing you need to do is the determination of dimensions. Next, you need to modify the dimensions. Once the dimensions are being modified, next is preparation of the drawings, and next, the last step is the final preparation of the design report. Let us see one by one all the steps of this design procedure. Now you can see the first step in the design procedure is the definition of the problem. Now let us first define what is design. Design means step by step creation of something new or modifying the existing things in such a manner that the need of the customer is satisfied. Since we have to satisfy the need of the customer, we have to build a product which is going to satisfy the customer. So the design need to be done step by step in a proper manner. Now, the first thing that the person is going to face is that what is the problem? As you can see over here, what are the problems that we are exactly trying to solve? Once we know the problem or going deep down into the problem, let us see one example. If I want to design a scooter, then I need to give some dimensions. What kind of scooter is going to be there, whether it is available in the market or not, whether the people will buy that scooter or not. If such scooters are available in market and a better scooter we can give or not, that is what we need to do. So here I need to give the proper specifications, like the width is 700 mm, the length is 750 mm, the height is 1000 mm, the weight is 95 kgs. So this is a proper definition of a problem. I am defining that this is how the product is going to look. Let us proceed with the next step. The second step is synthesis. Now once I have designed something, if I have defined something, then I should give some synthesis to that. Synthesis means the process of selecting or creating a mechanism. Mechanism means giving a motion to it. You can see over here, this is a mechanism which is a single slider crank chain mechanism which is used in IC engine. So if an IC engine has to be built, the parts I have placed it properly. Next thing I need to give is I need to give the motion to that mechanism. So that is called as synthesis. Synthesis is a very crucial step of design procedure, because if the mechanism is not provided in a proper manner, the functioning of the whole machine will go wrong. Let us proceed with the third step. The third step is the analysis of the forces. As you can see over here, there is a 4-bar mechanism which is there. In and around the 4-bar mechanism, you can see there are various forces which are being applied. There are some forces which are applied in inclined manner. There are some forces which are applied in vertical manner. There are some forces which are applied in horizontal manner. So you should first need to understand where the part is being placed in the machine. If it is placed in a certain manner, then from where and of what amount forces are going to act on that machine part. So if such forces are acting, you need to do the analysis of the forces. You need to do the calculation of the forces. With that, you need to see how much load is going to act, what is the moment which is going to be created, how much amount of torque will be generated. So this step is all about the calculation of the forces and the other terms like moment and torque. Let us move to the next step. The next step is selection of material. Now there are n number of materials which are available. As you can see here, the polymers are there are metals, there are composites, there are ceramics. Then which material you should select? You should select materials on basis of availability, on basis of cost, On basis of mechanical properties, like if you want hardness, or whether you want ductility, or whether you want malleability, what sort of mechanical property is desirable. I'll give you an example. For example, if there is a material which you need should be a hard material, then hard material can be a cast iron or an alloy steel. Cast iron is brittle, but in alloy steel, if I'm adding chromium, then that material is going to become hard, as well as it is going to become corrosion resistance and wear resistant. So it depends on what sort of material you want for that particular mechanical part. The last thing is based on the manufacturing considerations, like how it is going to be manufactured and what parameters are going to act while manufacturing. So this is all about selection of material. We are also going to see selection of material in brief as we move further. Modes of failure. You can see in the diagram, the machine part, the rectangular part which is there, it is failing because of the compression force. So here I can say that the mode of failure is compression. There are several other modes of failure like tension, compression, shear. So part can fail in any manner. The design engineer in this step has to decide that the part is going to fail by which mode of failure. Once he is knowing by which mode of failure it is going to fail, so he can make the part stronger. He can strengthen the part so that the failure should not happen. The next step in the design procedure is selecting the factor of safety. Factor of safety, like you can see, is the ratio of actual stress to the design stress. Now, if I want to give you one example of factor of safety, let us take an example of an auto rickshaw. Let us say that an auto rickshaw has a capacity of 5 members. If I calculate average load of those 5 members, then 5 5s are 30, 300 kg would be the load. But you can understand that an auto rickshaw person never accommodates only 5 persons. He would want more people to accommodate so that he can earn more. Let us assume that he is taking 600 kgs load. But if there is a sudden bump over there, then an impact load is going to act. Whenever an impact load is acting, the magnitude of force gets doubled. So 6 2s are, the ultimate load is going to be 1200. But the load for which the auto rickshaw was decided was 300. So the factor of safety, like you know, is going to be 3 4s are 12. So factor of safety is 4. So factor of safety is sort of an accommodation that if some extra load acts, then the part should not fail. You can see the factor of safety is decided on basis of application. So whenever a design engineer is doing the design procedure, he should understand where exactly your part is placed, and on basis of that, how much factor of safety he should select. You can see here, on basis of factor of safety and material strength, one can decide the design stresses. So it is on the basis of the factor of safety you can decide what amount of stresses are going to act. The next step is determining the dimensions. Now, what sort of dimensions should be there of a part? Whether it should be wide, whether it should be of a proper height, everything should be decided in this step of the design procedure. What are the different loads? What would be the different types of stresses, whether they are the tensile stresses, whether they are the compression stresses, shear stresses, thermal stresses, what sort of stresses are going to act is all decided in this step. The theories of failure, whether it is a maximum principal stress theory, whether distortion energy theory, whether maximum shear stress theory, depends on all selection of material, whether it is a brittle material, whether it is a ductile material. On basis of that, you are going to select a proper theory of failure. So it has to be decided in this step. Next, what are going to be the permissible stresses? And on basis of permissible stresses, the factor of safety. So this step is all about determining the dimensions. Let us move to the next step. The next step is modifying the dimensions. Now see, always there is a chance of an improvement. So if you have actually defined a part in the previous step, you have determined the dimensions, then in this step you are trying to modify the part. You're trying to make it more usable. You're trying to make it in such a manner that it is not going to fail very easily. So we are going to do the selection of the standard parts. For example, there is no need of taking a nut or a bolt and manufacturing it. They are already available in the market. The standard nut bolts are already available in the market. Then why waste your time in manufacturing a different sort of nut and bolt if they are already available? Standard parts are already available. So in this step, we will go for standardized parts. Next step, we'll see whether the parts are convenient to the assembly or not. Now assemblies are type of bottom to top approach or top to bottom approach, where how easily I can open the parts, assemble and then disassemble. So here I need to select the parts, modify the dimensions in such a way that they are convenient to the assembly. Next, I need to see whether it is convenient for manufacturing or not. Obviously, while manufacturing or production, the part should be easily manufactured and lesser problems should be generated at that time. Then I should modify the dimensions in such a manner that the manufacturing will become easy. It will be convenient for me to do the manufacturing. Let us move to the next step, the preparation of the drawings. You can see here there is a draftsman which is shown in the diagram who is preparing the drawings. So here I need to give the proper dimensions to the part. I need to give the dimensional tolerances to the part. I need to see whether it is properly straight, parallel, circular. On basis of the tolerance, I need to find out that. I need to find out whether the surface finish is good or not. If the poor surface finish is there, then the luster will not be seen. The part will not look attractive. So I need to see whether the surface finish is given in a proper manner or not. I also need to give the geometrical tolerances. Like I said, parallelism, perpendicularity, symmetry, whether the part is having all these geometric tolerances, I need to find out in this step. I need to find out the special production requirements like heat treatment. For example, if I need to do annealing on a part, annealing will relieve the internal stresses from the part so that the part will not fail very easily. So if any sort of heat treatment is done, then I need to do the marking of the heat treatment in the drawings while preparation of the drawings. Finally, I need to prepare the assembly drawings with the part list so that the drawing is generated in such a manner that when it is going to go to the production department, there is no confusion at all. The production people can easily find out from the drawings what is happening and what they exactly need to do. The last step in this procedure, the design procedure, is the preparation of the design report. The design report should be compiled, created in such a manner that everything right from the first step to the last step is included in it, so that when a person reads a design report, he is very clear what is going to happen step by step, what is being done step by step, so that the final output product that I'm going to receive will definitely satisfy the need of the customer.